Air pollution and climate change. What are the problems with air pollution, and is it connected to climate change? There has been some confusion about climate change. Here is an analysis of the evidence for climate change and its consequences with some possible actions that could be taken to reduce the damage of climate change. In reality, there are two problems with air pollution. The simplest is air pollution by trace gases. Here, small amounts of dangerous gases, usually acids, are released in a chemical reaction, usually combustion. These gases have a bad impact on the environment and must be eliminated. A good example is sulfur in coal. The sulfur in coal is oxidized by combustion inside a power plant and is washed out of the atmosphere by rain, making acid rain. When enough acid rain is formed, it starts killing plants and fish. These pollution problems are readily traced and are usually not controversial. What is controversial is how to get rid of the pollution. Usually a procedure can be found, but it may be expensive. This problem will not be addressed further here. The more complex problem is air pollution that causes a composition change in the atmosphere. This is exemplified by the increase in atmospheric carbon dioxide and methane and its impact on Earth's average temperature. The theory and the best data indicate that if too much carbon dioxide and methane, greenhouse gases, get into the air, they capture the visible radiation, hold the infrared radiation and change the Earth's heat balance. This raises the average temperature of the Earth's atmosphere, and so it is called global warming. One thing that makes this theory controversial is that all fossil fuels generate carbon dioxide when burned, and the vast majority of our energy is obtained by burning fossil fuels, so it is very difficult, and expensive, to reduce the amount of carbon dioxide that is emitted. Therefore, there is a very strong motive to disbelieve this theory. Another problem is that the Earth has climate zones that move with average temperature, so the zone position changes as the average temperature increases. Thus at any Earth position, the temperature may be increasing, due to global warming, or decreasing, due to zone position movement. Critics ask which trend they should believe. The answer, of course, is that it is the average of the temperatures in all climate zones that determines the average Earth temperature. This average cannot be determined by a measurement in only one Earth position, and so it is still being argued. A third thing that makes this global warming controversial is the impact it may have on the Earth's livability. It may not be possible to just wait for the effects to become clear and then take action. We may have to decide on an action plan now. If indeed the Earth is warming, then several things will happen. The Earth's glaciers and ice caps will be reduced, and eventually disappear. Less of the visible radiation on the Earth will be reflected into space, and more will be captured, which will tend to increase the Earth's average temperature. Also, some of the ocean's most productive zones are under ice, so loss of ice may result in a loss in the ocean's fish production. The melted ice will raise the mean sea level and low-lying land will be submerged. If so, some of the most important and valuable real estate in the world will be submerged. The climate zones will move north in the northern hemisphere, or south in the southern hemisphere, and some old fertile agriculture zones will dry up and some new zones will be waterlogged. The consensus is that there will be a net loss of agricultural area. The oceans will warm and spread. This will kill many reefs in the ocean and cypress forests on the edge of the ocean where fish breed, with a resulting loss of fish production. Hurricanes will also increase in strength. The aerosols in the Earth's atmosphere, fog, dust, ice particles, sulfur dioxide, etc., will change. An increase will increase the amount of visible radiation reflected by the atmosphere, and this could decrease the amount of radiation absorbed by the atmosphere. Most experts expect an aerosol increase, and a resultant reduction in solar absorption. Most important, the permafrost in the Arctic is expected to melt. This will cause the vegetation frozen in this layer to decompose and emit methane and carbon dioxide that would raise the temperature more. Thus the warming caused by man would cause more warming caused by nature. Until now, mankind put carbon dioxide and methane into the atmosphere, and warming started. If stopped, a new equilibrium would form and the warming would stop, but at a higher average temperature. There are processes that absorb the new carbon dioxide and aid the formation of this equilibrium. Two of the most important of these processes are forest growth and carbonate rock formation by plankton. Clearly mankind is overwhelming these processes, because the carbon dioxide content of the atmosphere is growing rapidly. Part of this problem is that mankind is cutting the forests, but largest part of the problem is the greenhouse gases from fossil fuels. In the future, if mankind reduces his carbon dioxide contribution enough to drop below the natural absorption capability, there will be at least two warming processes that still grow: the loss of the reflectivity of ice at the poles, and the carbon dioxide and methane production by decomposing permafrost vegetation. If the effect of these processes rises above that of the natural absorption processes, the warming trend will continue without mankind's contribution. This automatic temperature increase is called runaway warming. The only way to stop runaway warming is to provide a new means of removing carbon dioxide from the atmosphere. The evidence shows the following trends. Some areas show a warming trend and some show cooling. A computer model is required to interpret the data, because climate zones are shifting as well as warming. Generally, however, warming trends seem to dominate. The glaciers and ice caps are melting. The melted ice does appear to be raising the mean sea level, although this measurement is more controversial. The mean sea level appears different at different Earth positions. The climate zones are moving north in the northern hemisphere, and south in the southern hemisphere. This results in desertification in some productive agricultural areas and waterlogging in others. The oceans are warming and some reefs are dying and some cypress forests are dying, and hurricanes appear to be increasing in strength. Aerosols in the Earth's atmosphere are changing, but they are hard to measure. New, more accurate measuring devices are just coming online. The permafrost is melting, especially in northern Canada and Siberia. Several computer programs that integrate these measurements exist and they are being tested. They show a climate warming trend, but the Earth does not appear to have reached runaway. The accuracy of these programs is not yet completely confirmed with data, but this accuracy is improving. Is action required? Many still do not believe in climate warming. A counter-theory has been proposed. This theory says that the warming trend that we observe is due to changes in solar radiation level and Earth rotation axis wobble. Since there is nothing we can do about these causes, these critics propose that we do nothing that would upset the world economy, and wait to see what happens. This procedure could be very dangerous, as we shall see. Suppose nothing is done. Then the following long-term bad effects are likely. The glaciers are part of the Earth's freshwater storage system. If they disappear, the rivers will tend to flood in the winter and spring and dry up in the summer. The ice shelves in the Arctic and Antarctic are excellent fish food producers, and if they disappear, this food source for fish may disappear. If the mean sea level rises to its maximum, some of the most important and valuable seacoast real estate in the world will be submerged. If climate zones move north and south, significant numbers of productive agricultural areas will be lost. If the oceans warm to the maximum, a large portion of the Earth's reefs will die, and many cypress forests will be damaged. This will damage the associated fish breeding grounds. These problems will cause the reduction of an important food source. The above effects have, for the most part, a limited bad impact on the Earth's livability. However, one impact of this cascade of events, the loss of reflective ice and the melting and decay of the permafrost, may cause runaway warming. Inaction would lock in all these bad effects and open us to many future problems that are even worse. If runaway is possible and something can be done, action now is absolutely required. The solution, a practical and economically positive solution, may be possible without damaging the global economic system. This consists of an energy-generating system that can reduce carbon dioxide emission and sequester the remainder. Specifically, conservation, which would consist of substituting for fossil fuel power plants, O nuclear power plants where economical and safe. O deep thermal well power plants where economical. O ocean-based wind and wave generators and solar cells to provide both baseload energy and portable fuels. O electrical cars with solar cells to extend range. O alcohol and oil from waste wood, algae and kelp for portable power plant operations such as aircraft, trains, cars and trucks. Sequestering, which would consist of putting the carbon dioxide in the deep rock formations by use of deep thermal wells. Deep oceans by freezing the carbon dioxide and sinking it below the thermocline. There is a major problem with sequestering, however. Both the deep thermal well and the ocean-based wind and wave generators are being developed by small companies that, under normal development procedures, would not be expected to have a large impact for 30 years, and would not be expected to start reversing the warming trend for 40 to 50 years. Now the ice caps and the permafrost layers are expected to melt in 15 to 25 years. Thus we may be in a state of runaway global warming before the solution can come online. Timing may be important. Timing and the overall capability. This situation contrasts with other green energy producers such as solar cells. Solar cells have a serious production limit caused by a shortage of both worker skills and refined solar cell materials, and could not ramp up into the dominant energy producer in a timely fashion. A useful addition to the solution would be a process to sequester carbon dioxide from the atmosphere. However, there are no currently available commercially viable ways to do this. Conclusion: there are steps that can be taken, however, that have a high probability of success, and will have a positive effect of the economy. First, nuclear plant construction should be supported wherever safety can be achieved as a replacement for fossil fuel plants. Deep thermal well generator development and construction should also be supported as a replacement for fixed fossil fuel plants. Also, research for carbon dioxide sequestration should be supported as well as any other commercially viable alternate energy sources being developed now. The possibility of climate change due to carbon dioxide emission is controversial. Many are not convinced that it exists. It cannot be ignored, however. If it is ignored, there is a possibility that it will turn into runaway global warming because of the thawing and decay of permafrost vegetation, and the loss of the reflective ice caps,